Hi everyone. Now that we have talked about the order of operations, I think we are ready to move into a concept known as evaluating expressions. So basically, we are going to utilize the order of operations to simplify these expressions. But when we add in that word evaluate, it means that we have variables that we have to substitute a number for and then use the order of operations to simplify those expressions. So we're allowed to do that based on this property known as the substitution property. If A equals B, then A may be replaced for B in any expression. So in this case, we're told we want to evaluate A, B squared plus C when A equals 2, B equals 4, and C equals 7. Once you have set up the expression, we are going to follow PEMDAS in order to simplify. So we'll start with the exponents since there are no parentheses. 4 to the second power would give us 16. Then 2 times 16 would give us 32. And 32 plus 7 would equal 39. So pretty straightforward in terms of evaluating here, as long as we remember to utilize the order of operations after we substitute. Now, the one big thing, and students constantly are forgetting to do this, is the most important rule in algebra. So, hopefully this is something you see that it's most important, something we're going to remember for a while. You must put parentheses around negative numbers when you are substituting them into an expression. If you're substituting positive numbers, parentheses don't really matter. But every time we substitute negative numbers into an expression, we must use parentheses. Now, my suggestion would be just to get in a habit of every time you substitute numbers, utilize parentheses, whether they're positive or negative. It's a good habit to get into to avoid mistakes down the line. So you'll notice our first example, we're asked to evaluate 3x squared minus 4x when x equals negative 2. So I keep the 3 and I will substitute negative 2 in parentheses for the x value. Now, if you're utilizing the calculator for any of these, you have to remember you type it in exactly as it is written. This is really negative 2 times negative 2 when you are squaring it. Two negatives are equal to a positive, so 3 times 4 minus 4 times negative 2. At this point, we will continue with multiplication. So 3 times 4 is 12. And negative 4 times negative 2 is positive 8. 12 plus 8 would give us a positive 20 for our final answer for our example. There are a few more examples here, numbers 1 through 4. You see a squared b minus b squared, and we're told a is 3, b is negative 4. Now we have two sets of exponents here. We have 3 squared, which is 9, and then we have negative 4 squared, which is 16. After we take care of the exponents, we look for multiplication. In this case, we have 9 times negative 4, which is negative 36, minus 16, and we get a result of negative 52. Now you see in number 2, it's the same exact expression, but we are told a equals 4 and b equals negative 7. I'll give you all a second or two, and maybe you want to give this one a try on your own. Once you have started the problem, you hopefully begin with the exponents, 16 for 4 squared and 49 for negative 7 squared. In this case, 16 times negative 7 is negative 112 minus 49, which is negative 161. Again, if you're having trouble simplifying any of these, please utilize the calculator feature that we discussed on your Chromebooks in order to help with each one of these steps. Now in number 3, be careful. The negative is actually within the original expression. So for number 3, the negative will remain on the outside of the parentheses as I substitute 2 for y and negative 4 for x. So in this case, we will simplify the exponents. 2 to the second power is 4, and then the negative should remain on the outside. Bring everything else down. And as we look at our multiplication question here, negative 3 times negative 4 is positive 12, and 12 times 2 would give us 24. So when I combine negative 4 and 24, my final answer for number 3 is 20. Same idea on number 3. The negative is in the initial expression. I'm substituting a negative 3 for y and a negative 5 for the x value. The y value is negative 3. So follow the same process. We start with the exponents. Negative 3 times negative 3 is 9. Bring down the negative that was in front of that piece of the expression. And then we will do some multiplication here. Negative 3 times negative 5 is positive 15, times negative 3 is negative 45. So in this case, when I take negative 9 minus 45, the result will be negative 54. That should complete the front side of this worksheet. At this point, if you want to flip the page and look at a few more of the examples on the back, we have 5, 6, 7, and 8 left. Now, I'm going to do one more of these with you. I'm going to look at number 5. We're told that A is 3 and B is 4. Now, since we are substituting positive numbers, we don't have to use parentheses when we substitute the 3 and the 4. However, in number 6, we are substituting negative numbers, so in that case, we do have to use parentheses around our expression in number 6. So we will start with the exponents. 3 squared is 9, 4 squared is 16. 3 minus 4 is negative 1, which means we have 25 divided by negative 1. Our final answer for number 5 will be a negative 25. Same idea for number 6. Negative 3 to the second power. Multiplying two negatives, we get a positive 9. We get a positive 25. And then negative 3 minus negative 5 really turns into an addition problem. -3 plus 5, which would yield a 2 on the bottom. So as I add this, 9 plus 25 is 34, and 34 divided by 2 equals 17. You have two final questions, number 7 and number 8. The same expression is given for both, but you're given two different sets of numbers to plug in. I'd like you to practice substituting those numbers and plugging them in, and when you are done, please submit your answers for questions 7A, 7B, and 8A and 8B. If you have questions, please reach out to me in Google Classroom. Have a good day.